plate tectonics. That's what this is called. So the Earth's surface sits on a layer of rock called the crust. You've probably heard of that before. The crust is the outermost layer of the Earth. The Earth has many layers. The crust is part of something called the lithosphere. So the crust is part of the lithosphere. This lithosphere is not continuous, which means it's not one piece. There's many pieces, it's kind of like a messed up puzzle. Or like if you were to take like a potato chip, like a big potato chip, and break it into a couple different pieces. All together, it makes up that one potato chip, but of many different pieces. So it's not continuous, and these pieces are called tectonic plates. So on that map below, there's a rough outline of each one. All the arrows and the red lines are where the plates meet or are moving past each other. I know it's hard to see. I have some better pictures on the upcoming slides. So the Earth's surface is covered by a layer of rock called the crust. The crust is part of the lithosphere, and it's not continuous. It's made up of large pieces, and those pieces are called tectonic plates, like a big moving puzzle. So that should take you through this here with the notes. How this is working is next to each one, I have a number for the slide that it's on. So we should have everything up through slide 1 here done. Any more time? All right, going once, going twice. Next slide. All right, so here is a blown up picture of the first one that we did with the drawing. There are 7 large and several other smaller plates that cover the Earth. So we normally talk about the large plates. There are a bunch of other little ones, like if you look in there, like you got the Philippine plate, the Cocos plate, Juan de Fuca plate, the Nazca plate. Those are all like small ones, but the big ones are Eurasian, North American, Pacific, Australian, South American, and African plate. So those are the big ones. Now, think about where we live. All right. So we are in the middle of a plate. So there are 7 large and several smaller plates that cover the Earth. So again, 7 large and several smaller plates that cover the Earth. We are smack dab in the middle of plate 2. So right where my mouse is approximately Cincinnati. I don't know. Yeah, maybe there. So we're in the middle of the North American plate. The North American plate covers all of North America. And it even goes up into a little bit of Russia, and it covers like far northern Canada as well. If you look closely, there's some plates that directly border countries, like the African plate, the Indian Australian plate, and the where's the other one? The North American plate's another one too. It's right on the edge of California, is rubbing with the Pacific plate, and same with the African plate. That's why you can normally find a lot of earthquakes and activity there, which we'll get into in a little bit. So these tectonic plates move or slide over each other, and this over the asthenosphere. So The lithosphere is the top. All right. So again, if you want to think about the lithosphere, uh, pretend like the lithosphere would be the crust would be like the cheese on a pizza. It's the tippy top of it. It's not getting into the dough or the sauce. So the asthenosphere is below the lithosphere. The closer you get to the Earth's core, the hotter these layers of Earth get. And they are made out of rock and molten iron. And when you heat up things, they get more liquidy. Uh, and so if you want to think about a candle, if you heat up a candle, it turns to wax. And the wax drips and runs, but when it cools down, it slows down and stops again. Or think about pancake syrup. If you've ever taken cold syrup like out of the fridge, or it's been sitting out at room temperature a while, if you pour it, it pours slow and it slides around on your plate slow. But if you stick that in the microwave and heat it up really hot, it comes out like water liquidy, like really fast moving and thin. So the asthenosphere is warmer and heated hotter, so it moves. It's moves and it's heated unevenly. So there are parts of it that are like warm and liquidy, and there's other parts that are cool and hard that don't move. So all of those wonderful things make up the tectonic activity that we experience on planet Earth. And these plates can either move towards each other, away from each other, or past each other. So they're either going to go moving and collide and crash into each other, they're going to split and slide apart from each other, or they're going to brush past each other like you would brush past somebody like walking down a crowded hallway. They do one of those three actions, and all those actions have different consequences for us on the crust. We're going to talk about those in a little bit. So that should take us up through this here. So that should take us up through tectonic plates 3. Anyone need more time? Okay. All right. So next up is the more tectonic plates, and we're talking about the directions that they move. So when plates move away from each other, new lithosphere is created. So that's in that bottom left-hand picture right here. Plates moving away from each other. They split apart, and then magma from within inside the Earth comes up, and it kind of fills in that land space like glue or like paste, and then it solidifies. Kind of like think about like if you get a cut and your skin splits apart, then your body will form new cells to fill that gap, and new cells are created. When plates move towards each other and they crash into each other, one will go underneath the other and it will be destroyed. So that plate will get ground up and mashed down into the earth. And as it moves farther down, it gets hotter and hotter and hotter. And it'll end up melting it, and it'll become part of the Earth's inner uh, atmosphere, if you will. And we'll get into that in a couple days about how the inside of the world works. And then when they grind past each other in the bottom right picture, they just cause disturbances like earthquakes. Kind of like if you've ever pushed like a dresser or a desk across the floor, it grinds past the floor and it causes it to shake or vibrate. If you ever moved one of the desks in my room at school, that's exactly what happens. There's a lot of shaking that's involved. So that's where earthquakes come from, is this grinding of the earth past each other cause vibrations. All right, next up. So I don't know if you guys have ever heard of New Zealand. I'll type it in. So New Zealand, we're gonna watch a video about New Zealand. All right, so New Zealand is right here. It's like this small island off the coast of Australia. And it is. Google cannot calculate driving directions. All right, so it's literally the other side of the world. So if we're right here in Cincinnati, New Zealand is all the way past Hawaii. Lost it. All the way down here. So as you can see, it's very far away. But there's a lot of activity there, and that's what we're going to talk about in this video. Oh, oops. Um, Hold on a sec. All right. All right, so why are there so many earthquakes in Australia? Okay. Put it in the chat. Why are there so many earthquakes in Australia? A, B, C, or D? Okay. So let's rewatch that again. A trench. There it is. So it's along the plate boundary where the two collide and go underneath each other. That's why there's so many earthquakes in New Zealand. All right. I'm going to skip the rest of the video because we're a little short on time, but you can watch it on your own if you go back to the notes that are attached to Schoology. All right, so there are two types of plates that can cover tectonic, two types of crust, I mean. You have oceanic and continental. If you think about it, they mean exactly what they sound like. Oceanic means there's an ocean on top of it. Continental means that there's a continent on top of it. So if it's an oceanic crust, then it's going to be more dense and it's going to be thin. All right, these are called oceanic plates. And if you think about it, oceans carry a lot of water, duh. And if you get something wet, it weighs more. So like if you got your clothes all wet, you would weigh more. I don't know if you've ever gotten, your clothes wet or got drenched. You're heavier when your clothes weigh more. So a continental crust is less dense because it's dry but it's a lot thicker. This is made up of all types of rocks and minerals, and these are called continental plates. So, quick physics lesson: something that is more dense will sink than something that is less dense. So, for example, oil and water. If you ever mixed oil and water together, oil is less dense than water, so the oil will float on top of the water. But if you drop like a penny in the water, a penny is much more dense than water is, so it'll sink to the bottom. So when oceanic plates collide with continental plates, they go underneath each other. So that's like what it said in the video. The Australian plate was the oceanic plate covered by ocean. It was diving under the continental plate of New Zealand. And we're going to label this in our notes. So what we're going to do is double click. Your notes should look like this. Double click on it. And you can go ahead and label these parts. So this was the lithosphere. Okay, this is the continental crust. Here is the ocean. All right, so this is the oceanic crust. And then finally, below it, so the lithosphere sits on top of the asthenosphere. So your drawing should look like that, with each part labeled. Okay. So finally, that brings us to the last part of the tectonic plates. We're going to be answering these two questions. They're going to be on the screen, and I'm going to talk about them. Okay, so first, the question is, why is it important to know what type of plate or type of crust covers a plate? It's important to know because that type of crust determines what happened at the boundary between the plates. So if you have two continental crusts or two oceanic crusts coming together, something different will happen than is if you have an oceanic crust and a continental crust coming together. So the first answer is the type of crust determines what happens at the boundary between the plates. Specifically, all right, this is the second answer. So it asks you what happens when an oceanic plate collides with a continental plate. And why is when an oceanic plate converges or collides with a continental plate, the oceanic plate sinks below, all right, forget that TS, sinks below the continental plate because it's more dense. So it sinks below the continental plate because it's more dense. Think of it, it's like water soaked. All right. Any others? You guys need any slides? That brings us to the end. Okay. So second one. Here's 5. And then number 2, Marcus, is 7 large and several smaller. Did you hear me, Marcus? Okay. All right, and just a heads up, I will be posting this on YouTube as well if you want to rewatch the lesson. And I will post go at your own pace slides at the lesson too. So if you need to go back and finish copying anything down, you can go back and do that. There will be a link and a document attached to the assignment for today. When you're done, make sure you submit it. And if you are done, you're free to go. And I'll see you guys tomorrow.